Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos, Gobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 2. It says compound A and B are hydrocarbons, and then we are given compound A and compound B, as we can see there. Then 2.1 says define the underlined term. So we must define hydrocarbon. So what is hydrocarbon, or what are hydrocarbons? We say these are compounds or organic compounds that consist of hydrogen and carbon atoms only, right? So these are compounds that consist of hydrogen and carbon atoms only. So that's our definition of hydrocarbons. And then 2.2.1 says write down the IUPAC name of compound A. But before we can write down the IUPAC name, let's start by drawing the structural formula for compound A so that we can correctly give the IUPAC name. Okay, so now starting from up here, we can see that the carbon is bonded to 3 hydrogen atoms, and then it's bonded to another hydrogen that is bonded to 2 hydrogen atoms. But down here, it's bonded to a carbon that is bonded to a hydrogen atom. And then this carbon is bonded to a carbon with 3 hydrogen atoms, making a methyl branch. And then we have C bonded to 2 hydrogen atoms. And then we have a C forming a double bond there. And then we have 2 hydrogen atoms. So we have complete number of bonds here, 1, 2, 3, 4. So that means we can no longer put anything there. Then this is carbon bonded to 3 hydrogen atoms. So this is our structural formula for this molecule or this compound. And then now to come up with the IUPAC name, let's first identify the longest chain. And then we have to start it from this side here up there. And then we go all the way. If we count from 1, 2, 3, 4, 5, you can see that we have 5 carbons here, but then let's count 1, 2, 3, 4, 5, 6. We can now see that if we start from up there and then going all the way like this to form some kind of a zigzag shape, then we can see that we actually have 6 carbons in our longest chain, right? So be careful of that. Now to start numbering, we have to start numbering from the side where we see the disturbance. And then we can see here, right in the first carbon, we see a double bond. So we go 1, 2, 3, 4, 5, 6. And then let's check where we see our disturbances. We can see that in the second carbon, we have our methyl branch. And then in the fourth carbon, we also have another methyl branch. So having to give the IUPAC name for this, we will indicate the positions. We will indicate the positions of the methyl branches, which is in 2 and 4. And then since there are 2 of them, we will say dimethyl. But then remember now, the longest chain has 6 carbons. So this needs to be hex. And then indicating the position of the double bond that's in position number 1. So that's hex -1 in, right? So 2,4-dimethyl hex 1 in, and that becomes the IUPAC name for compound A. So we were answering 2.2.1. Okay. Now let's go to 2.2.2. It says the general formula of the homologous series to which compound A belongs. So we've already identified that because of this double bond, compound A is an alkene, and then the general formula for the alkenes is CnH2n, right? And then 2.2.3 says the structural formula of compound B. right? So allow me to just erase everything now. To draw the structural formula, to write down the structural formula of compound B, let's first start with the longest chain here, which is heptane. Hept means 7 carbons. So we're going to go 1, 2, 3, 4, 5, 6, 7. And then to check our disturbances, we can see that we have a methyl branch in 2 and 5, and then we have an ethyl branch in number 3. So let's start with the methyl branches. We have 1 in number 2, carbon number 2, and then we have another one in 3, 4, 5, carbon number 5. So let's indicate it here. But then in carbon number 3, if we choose to count from this side, we can see that we have an ethyl branch. Now in ethyl branch, that's 2 carbon atoms and 5 hydrogen atoms, right? So there we go like that. And then now let's indicate these ones here. So all we have to do is just fill in the hydrogen atoms, fill in the hydrogen atoms where we need to, fill in the hydrogen atoms, right? And then just like that, we have drawn the structural formula for compound E. That's 3-ethyl-2,5-dimethyl heptane. So we were supposed to indicate it like that. Then 2.2.4 says, name of the solution that can be used in the laboratory to test whether compound A and B are saturated or unsaturated. We call that one the bromide solution, right? We call it the bromide solution. Okay, now let's proceed to 2.3. 2.3 says, consider the following compound. We are given this compound here, and it says 2.3.1. Write down the homologous series to which this compound belongs. So first, let's try to write our structural formula so we can see what type of homologous series is this one, right? Then we have the C bonded to 3 hydrogen atoms, then followed by the C bonded to 2 hydrogen atom, and once again C bonded to 2 hydrogen atoms. Then we have a C bonded to a hydrogen atom, but then we have this O here. So we know that right there we should have a double bond oxygen. Now at this point we can all see that this is what? It's an aldehyde. So every time you are having the CHOR there, so always note that it is an aldehyde. Then 2.3.2 says name of the functional group. What is the name of the functional group of an aldehyde? We know that we call it a 4-mile group, right? It is called 4-mile group. Then 2.3.3 says IUPAC name of the chain isomer for this compound. IUPAC name for the chain isomer. So in order for us to have a chain isomer out of this compound here, all we have to do is just create a branch, create a methyl branch, right? So we can form our chain isomer just by simply doing this. Let's create a methyl branch down here, and then as long as we still maintain that we will have 4 carbon atoms, then we are good. So we still have 4 carbon atoms. That means also the number of hydrogen atoms are the same: 1, 2, 3, 4, 5, 6, 7, 8, and then also here 1, 2, 3, 4, 5, 6, 7, 8. So we still have the same molecular formula, that's C4H8O, and then also this one, it's C4H8O. But then what we have created now is a chain isomer. So this is straight chain, but this is a branched chain. And then they want the IUPAC name. Let's not get carried away. The IUPAC name for this one is now what? 2-methyl, but then our longest chain now has 3 carbon atoms. So this is propanol. So the IUPAC name for the chain isomer is 2-methyl propanol. Then 2.3.4 now says structural formula of the functional isomer. So if we have that this is an aldehyde, the compound that we have here is an aldehyde. We know the functional isomer to an aldehyde is a ketone. You will still remember cake. So cake simply means that your aldehyde is a functional isomer to the ketone, and your carboxylic acid is a functional isomer to an ester. So now what we need to draw here is the ketone, right? So to indicate the structural formula of the functional isomer, let's indicate it here. Structural formula of the functional isomer, we have 1, 2, 3, 4. So we should still maintain that we have 4 carbon atoms, and then we can just shift our double bond to the second carbon there, and then this makes it a ketone. This makes it a ketone. Remember, if the double bond oxygen is in between the carbon that is in between other carbon atoms, then it makes a carbonyl group, which is the ketone. Okay, now 2.4, consider the compound below. They say 2.4.1, write down the IUPAC name of this compound. So once again, let's start by breaking down this, right? So we can see that our carbon there needs to be bonded to a carbon that has 3 hydrogen atoms, but then not only 1 but 2 of these carbons that have a carbon bonded to 3 hydrogen atoms. Then again, this same carbon must be bonded to what? An OH, a hydroxyl group. And then we have the carbon that is bonded to 2 hydrogen atoms, which is this one now, and then followed by another carbon bonded to 2 hydrogen atoms, which is that one, and then to close it off with the carbon that is bonded to 3 hydrogen atoms. Okay, so to give the IUPAC name of this compound, you can see that if we can start numbering from this side here, this is 1, 2, 3, 4, 5. So the name is now what? 2-methyl, and then our longest chain is 5, so it needs to be pentan. But then we can see our hydroxyl group also again is in number 2, so -2 odd. So the IUPAC name for 2.4.1 is 2-methyl pentan 2 odd. Then 2.4.2 is asking, is the compound a primary, secondary, or tertiary alcohol? Give a reason for the answer. Now let's look at this. Remember, we need to locate the carbon that has the hydroxyl group. So this is the carbon with the hydroxyl group. And then now let's check how many other carbon atoms is it bonded to. So we can see that it is bonded to this carbon atom here. It is bonded to this carbon atom, and then it is also bonded to another carbon atom. Because this carbon with the hydroxyl group is bonded to 3 other carbon atoms, we say it is what? It is a tertiary alcohol. So for 2.4.2, we're going to say we have a tertiary alcohol. Now they say give a reason for the answer. Why do we say it is a tertiary alcohol? Because the carbon with the hydroxyl group, which is the OH, is bonded to 3 other carbon atoms. Okay, so the carbon with the hydroxyl group is bonded to 3 other carbon atoms, or you can say the carbon with the hydroxyl group is surrounded by 3 other carbon atoms, right? Okay, so that's how you were supposed to tackle all of this question for a total of 19 marks. And then please press the thumbs up button if you've enjoyed the lesson and then you've also found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.